A chemical change involves a change in composition. So how can you tell if the change you're observing in the lab, in fact, or observing in nature, is in fact involves a chemical change? Well, the surefire way of knowing is to monitor the substances that's in your sample that you're observing. Okay, if you have transformation of one substance to another, you can do tests for the substances, then you know for sure. But in general, if you're just looking at observations, if you can't do that, then one thing you could do is you try to explain what you're seeing in terms of what must be going on at the atomic level. If you can explain what you're seeing by just thinking about formula units unchanged, like molecules unbroken, and they're just moving apart or closer together, then most likely what you're seeing is just a physical change. So for example, melting or vaporization, sublimation, changes in physical states are just physical changes. They're not chemical changes. Okay? So there's some signs that a chemical change has occurred, but like I said, these are not always a guarantee, but that you're dealing with a chemical change. But most likely you probably are. So if you see an unusual color change, if you mix something yellow and blue, okay, and you see something green, your perception of yellow and blue being green, mixture of yellow and blue being green, chances are that's not a chemical change. But if you mix yellow and blue and you see purple, or you see red, then that's an unusual color change. That would be a chemical change. There's a change in odor. You mix two things and something stinks. And that's after that, then that probably means a chemical change has occurred. And production of new odor suggests the formation of a gas. So molecules that's responsible for that odor would be produced as a gas that travels through the air, gets inside your nose, docks into receptors inside your nose, sends nerve impulses to your brain, and your brain says, something stinks, or something smells good. All right? Burning, production of heat and light, is almost always pretty much chemical change when you see it. Precipitation, this has nothing to do with rain or snow. This is in chemistry when you mix two liquids, okay, and suddenly a solid comes out, and then that solid settles to the bottom of your test tube or your beaker. That's called precipitation. Gas formation, like I said, if mixing two things generates something stinky or something that smells good, that's a good sign that you're dealing with a chemical change. Or if you see bubbles, okay, effervescence is a technical term for this, or in layman's terms, fizz. That usually means you're forming a gas. So those are typically going to be small molecules, and that will be insoluble in water, like carbon dioxide is the most common one you'll see. Okay. Note that the absence of a visible change, if you mix two things and you don't see anything happening, it doesn't necessarily mean that no change has occurred. Okay. So that's just a negative evidence. So here are a few examples of chemical changes that you just should know that they are chemical changes. Okay, food rotting is an example of a chemical change. Burning of gasoline is a chemical change. When you treat your stain with bleach and it fades, that's a chemical change. Okay, digestion of food is a chemical change. Building of muscles in living things. In fact, living things is every living thing is just one big chemical factory. There's a lot of chemical reactions going on within living things. Okay, that's what living is all about, at least at the atomic level. Okay, physical changes, like I said, are changes in physical states, like boiling water or melting of ice, are just mere physical changes. There's no chemical change involved there. If you split a chalk in half, you cut something in half, that would be an example of a physical change.